Hello, 20-1 students. So today we're going to be looking at trig ratios of any angle. So if you remember in the last lesson, which was divided into two parts, we looked at the trig ratios for, basically we looked at angles in the standard position to start out with. And then if you remember in lesson 2, which was our last lesson, we were looking at some cases of special triangles. And so these are triangles that form angles that have specific trig ratios that we can use to solve different types of problems. And if you remember, I mentioned in that lesson that looking ahead, we wanted to kind of be able to put together the idea of angles in the standard position and reference angles with the specific ratios that we see in special triangles. And so today we're going to kind of be joining those concepts together. So just as a kind of an introduction, suppose theta is any angle in a standard position. And so just remember, standard position means you have the initial arm on the positive x-axis, and the terminal arm can be going, anywhere around those four quadrants we talked about from that starting position on the positive x-axis. So suppose theta is an angle in standard position, and you have a point on, this terminal arm here that has x and y components in it, and this point is a distance of r from the origin. So remember, the origin is where the x and y intercepts cross over. So if you're given the values of x and y of a right angle triangle, because remember that basically if we have this point coming out and we have the x and y components, we can kind of make that into a right triangle. We have our 90-degree angle there. And it's a little bit counterintuitive because we know that normally we think of the y value being here, but remember, you can just reflect that across the other side to make that angle, that triangle that includes the angle that you're using as a reference. And so it's asking you, which formula are you going to use to find this r value? Well, we know that if we have a right triangle and we know two sides of it, we can solve for the hypotenuse using Pythagoras. So normally we use a, b, and c as our variables for that. But this time let's put in the values that we see here. So a and b could be x and y, and c as the hypotenuse is going to be r because it's across from that 90-degree angle. So basically we would say r squared equals x squared plus y squared. Now, of course, if we actually want to solve for the length, we need to eliminate this square, which means we square root both sides to end up with r is equal to x squared plus y squared square rooted, right? So this would be our formula that we would use. And we will be doing that as we move forward. So this is going to help you out as we start looking at these different ratios. So you can use a reference triangle to determine the three primary trig ratios in terms of this x, y, and r that we see when we're working on a coordinate grid. So remember our different sine, cosine, and tan ratios, right? So it's SOHCA, TOA, because we have opposite over hypotenuse, and opposite over adjacent. We want to try expressing these ratios in terms of this diagram that we see up here. So basically for sine theta, we know that it's opposite over hypotenuse. Our reference angle is here, so straight across from that is going to be our opposite side. Connecting that angle to our 90 is going to be our adjacent side. And then, of course, our longest side that's across from the 90 degree is always our hypotenuse. Okay, so opposite side would be y over hypotenuse side r. So our ratio is going to be y over r when we're working with this particular angle. Cosine theta, we're going to have the adjacent side, so that's going to be our x value, divided by our hypotenuse, so again the r value. And then last of all, we're going to have tan theta, which is going to be the opposite side over the adjacent side, so it's going to be y over x. Okay, and so what you're going to see as we move forward is that regardless of which quadrant your terminal arm is in, we're going to see that these are going to be the same values that are used in each quadrant, right? Because x is always going to be the adjacent, basically. Y is always going to be the opposite, and r is always going to be the hypotenuse. Excuse me. So in order to summarize that, I want us to kind of create a chart that summarizes how these different trig ratios are going to work in each quadrant. I'm going to pause the video a quick second so that I can sketch in my different like quadrants, because we're going to be doing a little practice sketch of each one. So I'm just going to pause this. If you want, you can do the same and just sketch in the quadrant as you would see it, so that we can do some work with that. Okay, so we're back. So this is what I meant by, right, just sketch out each quadrant. So we're going to start in quadrant 1 here, which we know covers angles that go from 0 to 90. So here's our theta, can be any angle between those two. Now the important thing to keep in mind is when we sketch it out like this, if we want to make these trig ratios, we need to have a triangle. So we're always going to add in our y component here. And so basically what we're going to have is going from here to there is going to be x, going up and down is going to be y, and then the hypotenuse or the terminal arm is always going to be r. The other thing we want to think about in order to make our ratios is that there's always going to be a positive and a negative component. So for x, if we're in quadrant 1, we know that x is positive. We also know that y is positive. And therefore, if you think about it, if you have two positive values and you need to solve for r, we know that x squared plus y squared, two positive values added together, are going to give us a positive value for the hypotenuse. Excuse me. Okay, so now we know kind of our ideas of positive and negative, which is going to be important for each section. So we'll cover that each time. And so what we want to think about is, what is our ratio, and is it positive or negative? So basically we have sine theta would be opposite over hypotenuse. So opposite is going to be y, over hypotenuse is going to be r. A positive divided by a positive means that sine theta is always going to be positive, so we're going to say greater than 0. Okay. Cosine theta is going to be adjacent over hypotenuse, so adjacent is x, and r, x over r, both positive values, so we can say cosine theta will be greater than 0 as well. And then last is tan theta, which is going to be opposite over adjacent, so y over x. So basically just like we found on the previous page, right? Y over r, x over r, and y over x, y over r, x over r, and y over x. So those are going to be consistent through the different quadrants. Now again, we have two positives being divided, so we can say tan theta is, oh, I didn't mean to put in a equal sign there because it should just be greater than 0. Okay, so now if we look at quadrant 2, we're going to get into stuff that's getting a little trickier. So our x value in quadrant 2 is negative. What about our y value? Hopefully you guessed positive. So then what would be your best guess for the r value? Well, if you square a negative, it's going to be positive, and then if you add another positive squared value, it's going to be positive. So our r value is once more going to be positive. And maybe from what I just said, you can extrapolate to the r value for the remaining two quadrants. Okay, but basically x is negative, and so when we write our trig ratios, what are we going to expect to see in terms of positive and negative ratios? Well, you would expect that any ratio that involves x is going to have a negative value to it, right? So for example, let's see, sine theta is going to be opposite over hypotenuse. So it's a positive value divided by a positive value, so we expect it to be positive, right? So sine theta is greater than 0. If you don't love these, like, oh shoot, no, I'm totally spacing on the name. The like equivalency kind of things. If you don't like those, you can always just write in sine theta is positive, right? So depending on what works best for you in your mind, you can write out either one. On the filled in notes, I wrote both. So I would have written positive and then also that as well. Okay, so cosine theta really quickly here is going to be adjacent over hypotenuse. It's going to be x over hypotenuse, which is r. So keeping in mind that because this is a negative value, what do we expect to see? Negative divided by positive is negative, so cosine theta should be less than 0. And then last of all, we have tan theta is equal to our opposite side, which is y, over our adjacent side, which is x. And so again, those are, so we have positive x and positive y and negative x. And so what does that tell us? If we have a positive divided by a negative, we end up with tan theta being less than 0, okay? Now quadrant 3, again, we have our x value is over here. It's to the left of the origin, and so that's going to be negative. We can kind of just sketch in our y value here. Y is going down from the origin, so again, that's also going to be negative. Now, what does that tell us about our r value? So think again, I asked you in the previous one to possibly extrapolate to the next section. If we have a negative squared value plus a negative squared, well, any negative squared gives us a positive value. So both of these are two positive values that are added together, so our r value stays positive, okay? So now if you couldn't extrapolate to this one before, maybe now you can, to our quadrant 4. Okay, so let's do our trig ratios. So we have sine theta is going to be opposite over hypotenuse, so negative y over r. Okay, and so that tells us that sine theta is going to be a negative value, which is less than 0, right? So what you could do here is add in like your negative. Cosine theta, just as a quicker reference if you need it, cosine theta is going to be your adjacent side, which is negative x, over your hypotenuse. So that's r. And so that means that cosine theta is also going to be less than 0 or negative. And then our last one is tan theta, which is going to be opposite over adjacent, so y, negative y over negative x. And what does that tell us? So this one kind of sucks, but I'll just erase it actually. So negative y divided by negative x, remember that a negative divided by a negative cancels out, so we're left with a positive value. So that means that in this quadrant, tan theta is greater than 0. Okay, so it's positive. Okay, we could also look back here. So we had greater than 0 positive, less than 0 negative, less than 0 negative. So maybe you can start to see here that we're having a bit of a pattern, 1 positive, 1 positive. Let's not look back at that right now because that'll mess you up, but I'll talk about it once we're finished with all 4 quadrants. So now we move into quadrant 4. Let's sketch in our y component. So our x value is to the right of the origin, so it's positive again. Our y value is still below the origin, so that would be negative. And then again, our r value is going to be positive because when you square that, it's positive, and then you add another positive value. We're going to have a positive hypotenuse. Okay, so sine theta is going to be our opposite over our hypotenuse, so y, which is negative in this case, over r. And so yeah, we can say sine theta is going to be less than 0, which means it's going to be negative. Cosine theta is going to be equal to your adjacent side, which is x, which is positive, divided by your hypotenuse, which is r, which is also positive. So that means that cosine theta overall will be greater than 0. And that means it'll be positive. Last one, tan theta is going to be your opposite over your adjacent, so y over x. Our y value is going to be negative. Negative divided by positive is negative, so that means our tan theta is going to be less than 0, which means it's going to be negative. So again, you see one positive trig ratio, the rest are negative. Now the only exception to that is in this first quadrant here, where they're all positive, right? So they're all greater than 0, positive, positive, positive. And so from this pattern, we come up with something called the cast rule. And this is basically just an easy way to remember the rules, and it'll be a way to kind of check your answers really quickly and easily on a test to make sure that you've answered correctly and that you've remembered all your negatives and positives. So we basically do this as, I'll do this the same as I did for the filled in notes. So you start in quadrant 4, and then you just go counterclockwise and fill in the word cast. And basically, what it's trying to indicate is cast will only tell you which values are positive. So in quadrant 4, cosine is positive. In quadrant 1, all are positive. In quadrant 2, sine is positive. And in quadrant 3, tan is positive. And so all the other ones are going to be negative. So this just kind of helps you remember where the negatives and positives are, so that you don't have to kind of like redo that whole chart thing every time you're solving a problem like this. So now that we know all that, let's try to put it all together and solve some problems with it. Now the main types of problems you're going to be looking at are ones where you're given a point on a graph and you need to solve the ratios. The other possibility is that you're given an angle and you need to, and this is a angle in the standard position, and you need to solve for the ratios again, in this case, you're not looking for the ratio, sorry. You have to determine the exact value of sine 240. So remember, that means you can't just go into your calculator and type in sine 240 because you're going to get a weird decimal. So remember that we talked about last time, when you're asked for an exact value, it has to be in the form of a fraction, which may or may not contain like a square root or radical. Okay. The last type of a question that you'll get, and so you'll find that I've given you guys the breakdown of the basics of how to solve each one of these different ones. So finding an exact ratio with a given point, finding an exact ratio with a given angle, and then the last one you might have to do is finding an exact ratio with a given ratio, which sounds kind of weird, but basically you're given like tan theta is equal to 1/5, and so you need to figure out what the exact values are for, if you have tan theta, you need to figure out what would be sine and cosine of theta. Okay, so we'll go through those three different types here. So in the first one, find an exact ratio with the given point. And so we're told that we're at point 5, -2. So remember that when you have an ordered pair like this, it's always x and then y. So if we go to, like I think on the filled in notes, I tried to do this pretty precisely just because I'm like that. So basically I went down. Okay, so this is -2 on the y and 5 on the x. And so if I kind of try and line that up a little bit so that I get a half decent point kind of where those intersect. Okay, so now this point here is at 5 on the x and -2 on the y, and the point is going to form a line with the origin, right? So now I've put in my point, and just like before, I'm going to draw in the y value over here so that I make a triangle. So we have 5 here and then -2 here. And so like it says here, right, first you want to plot your point, make it into a bit of a triangle, and then label the sides that you know. So we have 5 and 2. What you might want to do is also just write in like 5 is x and -2 is y, and that helps you to keep track of your variables. So 5, -2, and then of course the third side is going to be r, which we do not know yet. So in order to find any of these trig ratios, we're going to have to know r as well, the hypotenuse. So how can we find that? Well, just the same as we did previously, where we're going to use Pythagorean theorem. So we're going to say r. So this was basically filling in point number 1. Now we're doing point number 2 for how we solve these. We need to find r, which we already determined at the beginning of this lesson, is going to be equal to x squared plus y squared. So basically x is 5 squared plus y is -2 squared. And of course we're going to square root that. So 5 squared is 25 plus -2 squared is 4 gives us 29 square root. Now 29 is not a perfect square, so we can't square root it like to any number other than something that will give us a decimal. And remember, we don't want to do that. So we leave it as an exact value, right? Because it's asking for exact ratios. So there's our R value. And then the last thing we want to do is determine the trig ratios as exact values. So important part there. So again, sine theta is going to be opposite over hypotenuse. So this is our theta right here. Just remember your theta is always going to be the angle between the nearest x-axis. So when we're solving problems like this, you should be using your reference angle in general. We'll look at the 240-degree one in a minute, but you're basically using reference angles usually. So between the nearest x-axis and your terminal arm there. So sine theta is going to be opposite, which is -2, over hypotenuse, which is r, which we said was root 29. Okay. Then the other thing would be cosine theta, which is going to be adjacent, so 5, over hypotenuse, which is r, so root 29. And then last one is going to be tan theta, which is going to be opposite, which is -2, over adjacent, which is 5. Okay, so these are our exact ratios. Do have a quick look and see if you can simplify. Now with the roots you won't be able to, and even with -2 over 5, that doesn't simplify down, so just always have a quick look. And then the last thing is to think about cast. I should have added that in there actually, because you should always at the end of a question think if your answers somewhat make sense as best as you can. Oh, and now look at me, I'm starting in the wrong quadrant. Okay, so just keep in mind cast. Actually, it's up there, but whatever. So this was in quadrant 4. So we know that cosine should be positive and all the other ones should be negative. And if we look at that, we have a negative value divided by, our value is positive, right? We had no negative there. So that's negative. Here we have a positive 5 divided by positive root 29, so that's cosine is positive. And then tan, we have -2 over positive 5, so overall the ratio here is negative. And so that matches with what cast tells us. So we can kind of check it off a little bit as being like, yes, we probably got those values correct. Okay, so if you want, pause the video a second, try this one here. You're given a point on the graph, and I drew you out a little component here so you can draw yours in and determine the values and then check your answers there. And then you can always restart the video to go on to the next question. Okay, so determine the exact value of sine 240 degrees. So with this one, we're looking at 240 degrees. So, I mean, let's be honest here. It doesn't really matter if you draw it in perfectly, but I always do just because I like it. So I know that if I go all the way around to this third line here, then I'm going to be at 270. So I just backed it off by 30 to draw my line. Okay. And so basically what I'm saying is if I start at the positive x-axis and I go all the way around, I'm going to be at 240. But like I mentioned in the previous question, what we want to be working with here is reference angles. Okay. Sorry guys, my computer's chirping at me. I'm just going to stop that. There we go. Okay. Also, I feel like this doesn't need to be quite that long. There we go. So yeah, so we want to use the reference angle here, like it mentions here. So the first part is sketch the angle in standard position. Honestly, what I would do is, because I know I want to do this every time, is to kind of sketch the triangle in as well. So I add in my y component. My angle that I'm going to be working with is theta r. And then I have the same, because I'm going to be looking for the exact value of sine. Sine is going to be the opposite side over the hypotenuse, so the sides I'm concerned with are going to be my y. So I need to keep in mind that because it's below the origin, that's going to be a negative value, and my r value. And I don't need to worry about the x value because that's adjacent. And remember, r value is going to be positive for every quadrant. Okay, so in order to find sine of y over r, I kind of need to have an idea of what angle I'm working with to get started, okay? Because I don't have any values for my side lengths. So when you're given an angle to start with, the first thing you need to do is find your reference angle. So remember, your reference angle is, you have a few different ways you can do this. If you know that this is 90 and I backed this off 30 from here, you should know that that's 60. The other way you can do it is to solve it using the kind of more like the formulas that we covered previously when we were looking at standard angles, where you would say, take the angle you're at, which is 240 degrees, and subtract off the angle of the nearest reference line, which is 180, and that's going to give you 60 degrees. So basically now we know that this is 60 degrees. Now all we need to do after we have confirmed that is to remember back to our special triangles what the side length ratios are for an angle that's 60 degrees. So use the special triangle to get the ratio. And so if you remember with this special triangle, if you remember, this is where I told you guys that I always just kind of remember the triangle and then I can solve from there. Remember, with a 60-degree triangle, it meant that you had an equilateral triangle, so the sides were 2, and this one is 2, but remember we only use half, so it's 1. And then over here, because you have 2 squared plus 1 squared square rooted, oh, wait a minute, let me think about that. Oh, sorry, not plus, because we're not looking for the hypotenuse. So remember, you're looking for the non-hypotenuse side. So it's 2 squared minus 1 squared, which gives you root 3 on that side. So that's something tricky to be careful with there. Okay, so now I just need to think, if this is my triangle, how did that relate? So remember, because this angle here was bisected, our 30 degree was up here. So this would be our 60 degree angle here. And so essentially what we have here is, if this is our 60 degree angle, the side across from it was the root 3 side. So that's our y side. And then the side across from the 90 degree angle is our hypotenuse. So this was our 90 degree. Across from it is 2. So now we know our 2 side values. Okay. And so basically what I can say is sine of 60 degrees is equal to root 3 over 2, right? So opposite over hypotenuse. Now the only problem with this is we're being asked for the exact value of sine 240, not sine 60. The nice thing is, and I mentioned this in the previous lesson, is that once you have your sine value for a special triangle, if it turns out that your value is in a different quadrant, then all you have to do is, so 60 degrees would have been in quadrant 1. We're in quadrant 3. And so all you need to do is just pay attention to your signs. So you can use your cast rule. You can also just use what you know about the positives and negatives. But I would personally just always stick with cast, because then you know you're safe. So we're in quadrant 3. T in quadrant 3 means that tan is positive and all the other ones are negative. So because sine is not tan, we know that this value has to be negative. Okay, so now I would just say sine of 240 degrees, right? I'm not working with the 60 anymore, even though it gave me the number value. The 240 degrees has the appropriate signs in terms of positive and negative. So we just said that sine will have to be negative here. So sine 240 is equal to negative root 3 over 2. Okay, so there's my answer. And just a note for how you write these out. I know some students get stressed, like, where do I put the negative sign? If the overall fraction is negative, you can just put the negative out front of the fraction. You can also keep the negative with the value that you know to be negative. So our y value is negative and our r value is positive. So you could have done negative root 3 over 2. Either notation is okay with me. Okay. So again, you might want to pause the video a second, try and figure out cosine 315 for yourself, and then the answer is down there so you can double check that if you need to. Okay, let's try example number 4. I'm trying to figure out where I'm moving all these papers out of order. There we go. Okay, last example here. Suppose theta is an angle in standard position with a terminal arm in quadrant 3 and tan theta is equal to 1 over 5. So we want to determine the exact values of sine and cosine theta. So when you're thinking about a question like this, what do we need to know in order to solve for sine and cosine theta? We need to know the opposite in the hypotenuse and the adjacent in the hypotenuse. So basically we need opposite, adjacent, and hypotenuse, which is all 3 sides. And tan theta only gives us opposite and adjacent. So we're going to have to, work with a method in order to solve for that remaining side. So the first thing you want to do is sketch your triangle in your indicated quadrant. Now, what I did in my filled in notes is, because I'm a little bit concerned sometimes with making sure that I have my sketch look somewhat to scale, what I actually did was kind of part 1 here where I figured out my triangle. I knew that I was going to have my x was going to be there, and then I was going to have an angle coming out, and then we always draw our y away from the actual y, so I knew I was going to have a side there. So I knew that this is kind of what my triangle was going to look like. And then my angle is always going to be in the origin corner here. So then I just wanted to figure out if my tan was 1 over 5, tan is opposite side, so that would be 1 here over adjacent side, which connects with the 90, so that'd be 5 here. So now I know my x and y values, and so now I can draw a more accurate kind of to scale drawing of this thing. So I'm going to go 5 centimeters is going to be for 5 on the x, and then I'm going to go down 1 centimeter for the y. And then I'm just going to connect that back to the origin. So there's my terminal arm. Okay, and then my y value is down here. It's -1. My x value is +5 up there. And this is where I have theta is in there. Okay, so basically now all I have to do is remember that in order to solve for those other ones, I needed to have the hypotenuse. So that's the next thing I want to figure out. So we talked at the beginning about solving for r. It's going to be the square root of x squared, so 25, plus y squared, -1 squared is 1. So we're going to have r is equal to the root of 26. Okay. Now I have everything I need. So always when you're solving problems like this, especially on a test, if you can't remember like the different steps for all of these, and I mean, I don't recommend trying to memorize steps. I always want you guys to try and think about the logical way to think through a question like this. So always read what is it that they want from you, and then identify what components are those in my grid or in my triangle, and how can I find those, right? How can I work back to find those? So now it's just writing out your trig ratios for sine. So sine theta is going to be opposite, which is -1, over hypotenuse, which is that r value, which was the root 26. I could always put that in there, right? So -1 over root 26. Okay, and then cosine theta is going to be adjacent, so 5 over hypotenuse, which is root 26. Okay. Oh, and then just be careful with that. Actually, I wasn't really paying attention to that because it's negative here as well. So that's a good little pointer there to remember. Just really quickly check with your cast, right? C-A-S-T. We're in quadrant 3. So only tan should be positive, and they gave that as 1/5. And here we have -1 over root 26 and -5, so those are both negative. So it seems like we probably did okay there. Okay, so that's our little confirmation. And again, you guys have a practice question to try on your own with the answers there, and then some homework to try out. Next time we'll be continuing on this lesson, the trig ratios of any angle. But again, I kind of divided this lesson up into 2 days so you guys have lots of time to cover it because it's quite a bit of work to do. So I will see you in the next lesson.